Hello students, welcome to SS Power Education. Today I am going to start with a new topic, that is subset, power set, proper subset and universal set. In the last video I have taught you how to solve set builder form, roster form, finite, infinite, empty sets, equivalent sets. Okay, so you can go and check the video part 1, 2 and 3. So let's get started. What is subset? So if A and B are two sets given in such a way that every element of A is in B, then we say that A is a subset of B. Here they have shown one example. A is equal to X such that X is prime, X is greater than 3 and less than 15. Okay, so the answer of A is, the elements of set A is 5, 7, 11 and 13. And B is X such that X is odd number, X belongs to natural number. Again, X is greater than 3 and less than 15. So now your X is 5, 7, 9, 11 and 13. So the elements in set A and B are more likely same. 5, 7, 11 and 13 are same. So every element of set A is in the set B. So A is a subset of B, and this is a sign of subset. But in case if the elements of set A is not the same in set B, then we have to write A is not a subset of B, and this sign is used. Okay, A is not a subset of B. There are some important results on subset. So let's read it. Every set is a subset of itself. That is, A is a subset of A, B is a subset of B, C is a subset of C, etc. Okay. The empty set is a subset of every set. Empty set is a subset of every set. If the elements are not written, if the set is empty, then also it is considered as a subset of set A, B, C, etc. Okay. Now, if A is a subset of B, then and B is a subset of A. If both are the subset, then A is equal to B. In this case, the example will be like here 5, 7, 11 and 13 is written. If in this set 9 won't be there and 5, 7, 11, 13 is only there, then both have same elements, right? In that case, A is a subset of B and B is a subset of A. Then A is equal to B. Okay, if both have same elements. And in case A is equal to B, then A is a subset of B and B is a subset of A. Both are same. Okay, if A contains n elements, then there are 2 raised to n subsets of A. Okay, that means there can be 2 raised to the power of n subsets of A. Okay, if A contains n elements. Okay, we'll see this in example. Okay, now is power set. This is explained here. The set of all possible subsets of a set A is called the power set of A, denoted as P bracket A. If A contains n elements, then P bracket A contains 2 raised to n sets. Okay, every element is a null set or an empty set. Okay, so first we have to take an empty set. Here elements of set A is 2 and 3. So that means 2 elements are there in set A. Okay, so your n will be 2. So 2 raised to 2 is 4. Okay, so we can make 4 subsets of A. First is empty set. Second is 2. Third is 3. Fourth is both. Okay, so empty set, first element, second element and both the elements. So your PA is that is possible subsets of A, this all. Okay, so similarly they have given so many examples. Okay, now is proper subset. Set A be any set and B be a non-empty set. Okay, let's set A be any set, okay, any number, but B is your non-empty set. Okay, then A is a proper subset of B, and the proper subset ka sign is this. Okay, if and only if every element of A is in B and there exists at least one element in B which is not there in A. In other words, if A is a subset of B and A is not equal to B, then only A is a proper subset of B. That means if A has 2 elements, B has 3 elements, okay, A is a subset of B and A is not equal to B, then and only then A is a proper subset of B. If both these sets have same elements, then this can't be a proper set. Okay, the only proper subset of a singleton set A is empty set. Okay, if there is only one element in your set, that is for example 2, then your empty set is the proper subset of that singleton set. Okay, so number of proper subset of a set containing n elements has 2 raised to n minus 1 proper subsets. Okay, so that means if A contains 3, 4, 5 and 6 elements, then the number of proper subset of A is, this is your formula to find proper subset. Okay, so it has 4 elements, so the power will be 4. So 2 raised to 4 minus 1, 2 raised to 4 is you say 2 raised to 4 is 16. Okay, that means 2 multiplied 4 times, 2 into 2 into 2 into 2, so that is 16. 16 minus 1 is 15. So the number of proper subset of set A is 15. Okay, now is universal set. Universal set is if there are some sets under consideration, then there happens to be a set which is a superset of each one of the given sets. Such a set is called universal set and it is denoted as this U or this sign. That means if there is a set, okay, like example A, B and C, there are 3 sets given. A has 1, 2, 3, 4, B has 2, 3, 5, 7 and C has 2, 4, 6, 8. Okay, so a universal set of this 3 sets will be all the sets adding all the elements of these sets, that is 1, 2, 3, 4 from this. Okay, 4. Now 5 and 7 from this, 6 and 8 from this. You should not repeat it. We have to write it 1. Now let A and B be 2 subsets of universal set, which is X such that X belongs to natural number and X is greater than 11 and less than 25. So your universal set will be 2, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 till 24. Okay, now your A is X such that X greater than 19. So 20, 21, 22, 23, 24 till 24 is your X. Okay, now B is X such that X less than equal to 18. So this can come only till 12. Okay, so you have to stop it till the universal set and increase it till the universal set last number and first number. Okay, With this, I'll end this video of explanation. In the next video, I'll explain you how to solve this exercise. Okay, it might be a bit confusing, but while solving, I will explain it again. You have to practice this particular lesson again and again. Okay, so do share and like my video and subscribe my channel. Bye.